Welcome back to a new day. Today you're going to learn something that every programmer needs, and that is how to work with SQL databases. You're going to learn when to use databases, what databases are, how to create databases, how to create tables inside databases, how to add, modify, delete data from database tables. So you're going to learn all that in more details in the next video and then in the videos after that. So we're going to work on the context of our real-world program, which is the event scraping app, which is this app here. But before we jump into the app, I first want to give you some introduction to databases. That's why in the next video, the programming tool of the day is databases. So please don't miss the next video. Then in the video after that, we're going to work on our application. So I hope that's clear. This is a very important day for you as a programmer. So let's move on. I'll see you in the next video. Sooner or later, it will happen that you will have to work with SQL databases as a programmer for storing and retrieving data. Now, SQL databases have some crucial advantages towards the other data storage solutions such as CSV, TXT, JSON, and other file storage formats. The two main advantages of SQL databases are speed and concurrency. When you store data in SQL databases and you retrieve data, you modify them, these transactions tend to be faster compared when doing the same things on files such as JSON and TXT and CSV. However, the advantage is not so pronounced when you work with smaller amounts of data. So when you work with smaller amounts of data, using CSV, TXT and JSON is still more advantageous because it's easier to set up. The other advantage of SQL databases is concurrency, which means that SQL databases do a great job for concurrent transactions, meaning that if two users of your app are doing the same thing in the app, some actions which modify the data in the SQL database, the SQL structure will take care to preserve the integrity of your data. So again, concurrency is something you need to worry about for larger apps where you have many users accessing the same amount of the same data set. So that was some introduction on what databases are from a theoretical perspective. Now let's look at them practically to see them at first hand, what it means to work with databases. So to work with databases, you need some sort of program, which can be a programming language such as Python, or it can be another program such as the DB browser for SQLite, for example. This is a graphical user interface program. And so before we jump into Python and interact with databases through Python, first we want to interact through databases with this program so that this will give you an initial idea what it means to work with databases. So please search for DB browser for SQLite on Google and then go to sqlitebrowser.org. And then please go to downloads and then you want to download one of these executables and please install that, and after you install it you should see something like this. If the font is smaller, in your case, please go to the settings and then you want to increase the font here and also in the database tab in here and also in the data browser here and also in the SQL tab. Right. So through this app you can do a series of things with databases. You can create a new database, you can create a new table inside the database, and you can add records, so rows in that table. So the hierarchy looks like this. So we have the database, we have tables, contained in that database, and then we have rows contained in those tables. So let's start from the top. Let's create a database. To create a database, you need to go to this button, New Database. Now, this program uses SQLite databases. So there are different database systems such as SQLite, MySQL, PostgreSQL, Oracle, etc. Now, all these have in common SQL. So SQL is the common structure, and it's also a language, which is something that you'll see how SQL comes to be a language. So all these databases that I mentioned are based in SQL, so we will use SQLite. So you need to create a database file. So please perhaps locate the project you have in PyCharm. So that would be app10 in my case. I have the project files in here. So in this project, in this folder, I want to create this database. So please specify a name such as data. Don't provide an extension because this program, DB Browser for SQLite, will add an extension automatically. So press on save. Now, the database is being created and it's asking you to add one table because the database needs a table, at least one table. So this window here is asking you to provide a name for that table. So let's say events, right? So in this program, we might have different tables. So events is one table. Perhaps later on we will expand this program by scraping some other values such as temperature or etc. In that case, you need to create a separate table because this table now is only about events. And now this table will have rows, and each row will have different columns, right? So it's like a CSV structure. Therefore, we need to add these types of columns for the events table. To add columns to this table, you should use this add button. So the first column will be the band, right? We have the band name, as you might remember from the app. So just to show you that when we run this program, so we have the band, we have the city, clone city, and then we'll have the date. So let's create these three columns in the database. So band, this will be text, right? So we have different types. So each column should have a type, and we declare that type when we create the column. So since band is just text, we press on text there. Then we add a new column. This will be city. This is also text. And then we add another one. This will be the date. Now, there are no specific date types for SQLite, so for this we will also use text. If you had numbers, for example, the number of band members, then you'd use an integer, for example. Or if you had something that was a float number, like the price, you'd use a real number. In this case, we only have text values, so press on text everywhere. And this now is SQL language. We'll talk about that later. So just take a look for now, and I'll talk about this language in just a bit. Press OK, and what that will do is it will add a database with a table inside. So now in database structure, you can actually see that you have this one table here, which is events, and the events table has 3 columns. And currently it has 0 rows. We haven't added any data, right? We haven't added any band or city or date. So this is an empty table, and you can see that in the Browse Data tab. So that's how the table looks like. These are the columns, and we have no data currently. In your folder where you created the database, you'll also see the file. So data.db in my case. That's a file. If you open it, you'll not see anything actually, because this is a binary file, so it's a non-text file. Therefore, we cannot view the data in a text editor. That's why we need special programs such as this DB browser, which accesses the data, and it allows you to perform actions such as create tables, databases, and add rows, which is something we'll do now. And we can do also all these things we can do also in Python. So first let's do them here so that you get a better understanding on what's going on. And that will not make it look like a black box. So next thing to do is let's insert some rows in the database. Now there are two ways to do that in this program. You either use this button here, you see, insert a new record in the current table, and then you want to click on that null value, just click once and maybe wait a second, and then type in a band name, for example, Lions, right? And something in the city, Lion City, for example, and something for date 2088, for example, dot October 10 dot, let me expand this, 15th. Press enter. And to actually write the data in the table, then you want to press on this write changes. There. So that will actually store that row in this table. Now, right, so we can use this button here because this graphical user interface lets us do that. But in Python, we don't have buttons to add data, right? In that case, in Python, we will use something called SQL, as I mentioned. SQL queries, so SQL language. And these queries will look like this. I'll give you the exact code later, but approximately the SQL query will look like this. Insert into events values. In parentheses, you provide the values, which could be single quotes, since we have double quotes in here. Let's say tigers for the band. Tiger city in single quotes, a comma again, and also the date again in single quotes, such as 288.10.14th. So that here now is an SQL query, and Python will execute that in the database. Now, if we get this query and go to execute SQL, this button here, and you paste that query in there, and then you go to this play button to execute that query, what that will do is it will enter those data. So that's the query. Make sure that this says query executed successfully. Otherwise you might have some typos in here, right? So that's the query. Now if you go to browse data, you will see that tigers were added to the database. There we go. So that's what SQL language is about. So SQL communicates with a database such as this data.db file here. So it communicates with that database, and in this case it executed the insert command, insert into command in the events table, and then it inserted the values. So that is an SQL command, that is an SQL command, that's two, this is the table name, and so these are the data. Let's execute one more query. Let's say monkeys, Monkey City, and 15th of October. press that play button, go to browse data, and there we have Monkey City. So that was how to insert new data to the database. Now, if you want to really write the changes, you want to press this Write Changes button here. So in Python, we also have some methods which will write the changes. So here we're doing this with this button. In Python, we'll do that with a method. After this, for example, we'll add something like .commit, and that will write the changes. Now, that was how to insert data, but how to query data. So Python will have to insert data at some point, and then it will have to query data to select data so that you can print them out and show them on web app or on a desktop GUI or on the command line. So to query data, you use the select command. You want to select all with that asterisk from events. Events is the name of the table. And then you usually want a condition, right? So perhaps the user is asking for events on the 15th of October, right? So in that case, you do where date is the name of that column which contains the dates, where date is equal to single quotes, and inside single quotes you enter the date. In my case, that would be 2088.10.15. So if I execute this now, this query, press on that, and this will show me all the rows which have date equal to that value. So that's how you select queries. And this is also a command which we can run in Python, and I'll show you that in the next videos. So this one in here, right? I'm just keeping them in here to have them handy later on when I use them. Something to note is that the select operation is not a write operation, so you don't have to write any changes because you didn't do any modifications in the database. You're simply querying data. Lastly, let's see at the delete command, how to delete some data. For this, we want to use the delete command from events where band is equal to tigers. Execute, go to browse data, and tigers has disappeared from the table. And make sure to perhaps write the changes to actually write the new update in the database. And that's what a database is. That's how you can interact with the database using SQL queries. Now it's time to go into Python, and I'll show you how we can send these queries to this data.db file. So I'll see you in the next video. Thanks. Hey, welcome back to Python. So in this video, we'll be working on interacting with an SQL database from Python. Please watch the previous video if you missed it, because the two videos are somehow related. So in the previous video, we created this data.db database. If you don't have that file, I've attached it in the lecture resources, so you can download it from there. So that file has an events table, which has these two rows for now. If your table has different rows, that's fine. So in this video, we still don't want to go and work with the app. We still want to do some practice with SQL and Python. So please create a new file such as example. I'll not add it to the Git repository, but you can add it if you like. So this is not related to the app. It's not part of the app. So here I want to show you how Python will interact with databases. So in the previous video, you saw how this DB browser for SQLite program interacted with the database. Now it's time to do this programmatically from Python. So SQLite 3 is a standard library, and this is something that you need to interact with SQLite databases. So you want to start a connection first. To do that, you do SQLite 3.connect, and inside the parentheses you want to supply the data.db file, or whatever name you have given to this file. So data.db should be in the project directory. And so this is a method, well, actually it's a function because this is a module. So if you go to connect and right click and go to implementations, you'll see that this is actually a function. Anyway, so that will create a connection object instance. If you print it out, don't expect to see anything impressive because we still have something else to do. We have to create a cursor object as well, which comes from connection.cursor method. Sorry, connection, so this variable. So this connection instance has a cursor object. And so the cursor serves as an object which can execute SQL queries using the execute method, which now expects one of those SQL queries. For example, select all from events where, so events is the name of the table, right? And then where, let's select all the rows where band is equal to lines. So the band column is equal to lines. We have 3 columns, right? So where band is equal to, in single quotes, we provide the value lines with a capital L. Yes, capital L. And at this point, this cursor object will somehow be modified. So think of it as a list. So at this point, this will contain the query data. It will contain that row, right? So this row inside the cursor object. So to print that out, you want to do print cursor.fetch all. This is a method, or you can store this in a result variable or rows variable. So cursor.fetch all and then print rows. Yeah, let's execute this. And you should see a list of tuples. Let's try to alter this a little bit. Instead of band, I want to provide the date column where the date is 2088.10.15. We have 2 rows for that. So let's say date is equal to 2088.10.15. Execute. This time we get a list of 2 tuples. Previously we got a list of 1 tuple. So now we get 2 because there are 2 rows which contain that date. So as you'll see now, this is indeed a list. So just do tuple. I think that's obvious, but just to make sure you understand what's going on here. So it's a list of tuples. And so now what you can do with this data depends on your application. Here we're just simply printing them in the command line. But you can do different things, as you'll see in the next videos where we integrate these queries into our application. So that was to query data. That was to establish a connection and a cursor. A small alteration of this would be this. Instead of doing all, you could do select band, comma, date from events, right? Store the rows in this, print the rows, and if you execute this time, this is the results we get from this print function. So now this includes only those columns, so band and date, band here, and date. So you don't have to write an asterisk if you don't need all the data. So that was query all data. This is query certain columns. Next is inserting new rows. So let's add 2 new rows to the table, but before we do that, you need to prepare a list of tuples, right? So that would be in the same format as we had them in here, right? So I'll just copy one of those lists, paste it here, and do some changes such as cats here, cat city, hens, and hen city. Let's change the date slightly, 17 here. So I'll store that in a variable, let's say new rows. You can split this list of tuples in here if you like. Then you want to refer to the cursor object and then to execute many this time. So that's execute, and this is execute many, which means you'll add multiple rows to the database. And here goes again the SQL query. So insert into events values, and here, as you know from the previous video, we can supply these parentheses, and inside here in single quotes you could add the values like this, right? But normally you'll have those values stored in variables, like is the case here, right? We have this list of tuples. So in that case the syntax will not be like this, but here you'll have to supply question marks 1, 2, and 3. We have 3 columns, right? We have the band column, the city column, and the date column. So then outside of the double quotes which wrap around the SQL statement, you want to provide a second argument. So this is a second argument of the execute many method. That's the first argument. The second argument is new rows, this variable. So that means that each of these values will go inside here, and this execute many method will take care of inserting those values into the corresponding positions in the table. And then we would do connection.commit. Remember, previously in the previous video we used this write changes button when we did some operations which modified the database. So this here, insert, is also an operation which modifies the database. Therefore we need to write the changes, and to do that in Python you use the commit method. So let's execute this. Run. Right, so the process was executed. We don't see any output because we're not printing out the data, right? So these were printed out at this point. So the Python interpreter runs the script and it shows you the current data, but then it adds these new rows and it doesn't do anything else here. It doesn't print out any rows. So if you want to see what rows you have, perhaps you want to temporarily comment this out, you can select them and press Ctrl# symbol on your keyboard or Command# symbol to comment multiple rows of code. And now if I do a query operation, for example, if I copy these and place them here, but note that these queries where the date is that value, right? So to query all the data, you want to delete that condition. You only want to keep select all from events in double quotes and execute. So that's what we get. So that's the printout of the last print function rows. So we have cats and we have hens, and yeah, that's it. So that was how to query all data based on a condition. This was how to query certain columns based on a condition. This was how to insert new rows. And of course, this list can have also only one tuple if you only want to add only one tuple. So it would be a list of one tuple. That would also work. And then we have this to query all the data. Right, so that's about this video. Thanks a lot for following, and let's move on with working on our real-world application. See you. Hey, welcome back. In the previous video you saw how to interact with an SQL database via Python. Now in this video we want to work on our app and implement SQL in here. So let me quickly do an overview of what this app does, because we were working on this yesterday. So I just want to refresh your memory. If we go down here, what the app is doing is it's executing over and over again using this while true loop. So in the first iteration we call the scrape function, which is this one in here. So the scrape function will get a URL and it will return the page source, right? So we store the page source in the scrape variable, then we extract only the event, for example Lions, city of Lions, and the date. So that's a string stored in extracted. We're just printing that out. So the string looks like this. It could be no upcoming tours or one of the events such as this. So this is being printed out now, and then we've got this line executes the read function. So read is here. So this returns the content of this data.txt file. This is where the data here are stored by the store function, which is down here. So if extracted is different from no upcoming tours, which means if we found a tour on the web page, right? So the web page is this one in here. So if the web page has a tour currently, and then if the tour is not in the content, in this content, so in this content, if the tour has not been added there previously, then we want to add that tour. So we call the store function, which is this one in here. So the store function will add that extracted value that we got here. And then we send an email telling the users that, oh, since this new tour, this new event was not found in the text file, that means it's a new event. So we send out an email, and we keep doing that, all that every 2 seconds. So we keep checking for new events on the website. Right, so now we want to change this. We want to implement SQL. So let's start again from this loop here. This is where the functions are called. So this is also known as the loop that runs the program, basically. And so we want to start from here. So let's see. While true, scraped is equal to that call, the function call. We don't need to change this. This is about scraping the data. It's not related to retrieving or adding new values. So that gets the page source, and then we execute the extract function, which is in here. That's also fine. So this parses that page source, the HTML. We print it out. Then we read the content, right, with the read function. So now, instead of having text files, we want to read the database. So let's create a database. First, go to the DB browser for SQLite. If you have the database there, that's fine. all you need to do is open database and go and locate that folder, right? And that is in here, data.db, open that, go to browse data, and perhaps you want to delete those data. So let's delete them, start from scratch. So please select them by dragging the cursor in here and then go to this button. You can delete them and then go to write changes to write the changes. So now this data.db file has a table event, as you can see in here, but it doesn't have any rows. So we get that string here, right? So which could look something like this. So let's say extracted is equal to that string. Now, what do we do with that string is we want to convert it into a list of different strings. And to do that, we would say row is equal to extracted dot split. We split it at the comma. So the different elements are split with commas. So that would produce a row list of 3 items. Now, some of these items will have some spaces, so perhaps you want to run a list comprehension on top of this list. So you can say item.strip. So strip will strip out each of these strings from unnecessary leading or trailing spaces for item in row. So now row is this list of strings without those spaces. So that's what we want to do in this function first. A row is equal to that, and then we strip out the items of space, and then in example.py we had this query all data based on a condition. So perhaps we want to copy that and place that code in here. The cursor has not been defined, so let's go and also copy these 2 lines. Right? Make sure that you have imported SQLite 3 as well. So where do we place those 2 lines now? Should we place them in here? Well, I don't think that's a good idea actually. I think it's a better idea to place them somewhere outside the functions, perhaps before the first function in here. I'm doing that because if you look at how the functions are executed, you'll see that this loop will execute that read function over and over again, right? So that means you don't need to establish a connection in every loop of the while loop, right? It's enough to establish a connection once and then work on top of that connection. So in fact, we should get the cursor from here and have it in here. So the connection itself should be outside, but the cursor should be inside here. So it refers to the connection variable, which is outside, right? Now the query cursor.execute select all from events where, well, now we have this row again, which looks like this. But what we can do is we can do this band city and date is equal to row, and that will give us each of those strings in separate variables and date as well. So I think this is better. So just do that in here. So we have band city and date, and then in here we say where band is equal to a question mark and city is equal to a question mark and date is equal to a question mark as well. And then outside of this, so that's the first argument of the execute method, and the second argument is a tuple of variables band, city and date. So for example, if lions is stored in this variable, then lions will go in this variable and it will be placed in this place here, in this placeholder. The question mark will be equal to lion. So we're asking our SQL database to give us all the rows where the band is that and the city is that and the date is that. So that combination of values is represented by a row. And then we get the rows, and you can print them out if you like to see them on the command line. But what you also want to do is return them, return the rows. So now the read function returns the rows, which is expected to be one row actually. So it returns that row from the database. So in here, content will basically be the row, right? But even better, I would like to get this line and place it underneath this, so that we only want to check the database when the value, the scraped value, is different from no upcoming tours, right? In that case, we want to see, for example, if the row is lions and the city of lions, etc., then we want to get that row in here. And then we want to say if not row, execute the store function. So why did I do this? Well, the function read, if it returns a row which exists, for example 1, 2, 3 with values, and then you say a row is equal to read, and then you say if row print yes, you get yes, because the function returns a non-empty list, right? But if that function was returning an empty list like this, and then you say if row, and then you get the value of that function with read, and then you say if row print yes, this time you're not going to get yes printed out, because when the function returns an empty list, that empty list is basically equal to false. So a non-empty list is like the true type and an empty is like the false type. So we check here basically if not empty. So basically here we're checking that if there are no such rows in the database, we want to store that new row. So now let's look at the store function, which is in here. So we don't want to work with text files anymore. We want to get that extracted value and perhaps convert it into a list also. And then do cursor is equal to connection.cursor. So it's good to have a separate cursor for this function and a separate cursor for that function. And then cursor.execute. So previously we used execute many in the example.py file to insert rows to the database, but that was the case when you have multiple rows. But for this application we only expect one list, so this will be one list with 3 items. In that case you can use execute and do insert into events values, in parentheses we have 3 values, right? 1 question mark, 2 question marks, 3 question marks, and then after that you say row. So that's one argument, that's the second argument. Row is a list of 3 items. It's not a list of tuples, it's just a plain list of 3 items. So each of those items will replace one of these question marks correspondingly, and these will be added to the database. And don't forget to commit the changes using the connection variable, which we defined on top in here, right? So now, before we execute anything, let's go to this program, refresh, make sure that there are no values here, right? If there are, please select them and delete them, and we're ready to run the program. So let's run the program. I've got an error related to the email because I changed my passwords earlier, so let me go quickly to my email function and put my new password here, right? And let's run again. So we've got no upcoming tours. Then we have a new tour, email was sent, no upcoming tours. This again, the email was not sent this time because ThanksSuave was added here already. Lines of the IDE. Now let's check if we actually got 2 emails or just 1 in the Gmail account. So that's my Gmail account that I'm using for this app, and it seems like we got only 1 email, so this is just like a minute ago, and we expected to get 2 emails. Let's check the database. Let's do a refresh. So we got 2 rows added here. So I think lines of the IDE was already there. So what I'll do is I'll try this again. I'll stop the program. I'll delete all these rows using that button and write the changes and run the program again. So here we are. Let's see, no upcoming tours. There we have the first event, email was sent. No upcoming tours. Again and again. And that's the second event. So email was sent this time. And let's check the email. So there we have 2 emails during the last minute. So it's working fine. And yeah, that's the complete code for this app. And basically, I hope you got an idea how SQL can be used. So you have a connection outside and then you repeat the execute methods in your functions when you need them. And always commit when you want to write the changes to the database, and always remember that the fetch all method returns a list of strings when used with execute, and it returns a list of tuples when it is used with execute many. So I hope that's clear, and if you have questions, drop them in the Q&A. Thanks a lot, and I'll talk to you later. Hey, welcome to today's student project. For today, your task is to improve yesterday's program. So yesterday's program was scraping temperature values from this web page. So that was a student project of yesterday. So today you want to modify this program so that it works by accessing an SQL database instead of working on text files. So what you built yesterday was something like this, approximately perhaps. So this program would print out the temperature which is extracted from this web page. And so that temperature is also stored in this data.txt file through this store function. So the data looked like this, date and temperature. Now, your task for today is to alter this function so that the function doesn't store the data in this file, but it stores them in a database table using the same data structure. So you should have 2 columns in that table, date and temperature, and store the date values in the date column and the temperature values in the temperature column of your table. You can create a database and a table through the DB browser program which I introduced you today in the programming tool video. So that is the second video of today. So that is the first task, to alter the store function of your main.py file so that the data are stored in a database table. The second task is, and this is optional, so the second task is to go to your web app if you did build a web app with Streamlit, because yesterday this was also one task, but this was also optional. So your task for the day is that instead of using pandas to read the data.txt file, you should use SQLite 3 to get the data from the database table where you are storing the data through the store function. So the output will be the same, right? But the data storage solution is different this time. So please get the data from SQLite 3, and once you get the data, please supply them in these X and Y arguments. So these are the two tasks for today. In the next video, I'll show you my solution. So see you there. Hey, welcome back. In this video, I'll show you my solution to the two tasks I gave you in the previous video. So the first task was to implement SQLite SQL in this app. So this app extracts temperature from this site. Now, what I did to implement SQL is first I imported SQLite 3 in here. I established a connection somewhere in here. And then I refer to that connection variable in here. So that's my store function. Once I get the date stored in a string, so the current date and time, including the hours, the minute, the seconds, then I create a cursor object using this method, and then this is my SQL query. So I insert into temperatures. So temperatures is my database table, which looks like this, date and temperature. So we have these two values. Temperature is a real number. So when I created a new table, I set the temperature column to be a real type and date to be a text type. And that's the query. To insert the now string, the date, and the temperature. So the temperature value, which could be 18, 19, etc., would be stored in this variable extracted, and then I get extracted and I place it here. So that will be a real number, a float. You could also use integers, but since temperatures are continuous data, it's better to use a float. And here I commit the changes so that the changes are written to the database. So that was the first task. The second task had to do with the app. So that's my code for the Streamlit app. So I import SQLite 3, I establish a connection in here, I create a cursor object, and then this is my SQL query. So I select from date. So I'm selecting the date column, the entire values of the date column from temperatures. And then I store the results in this date variable. So at this point, date will be something like a list of tuples like this, and inside each tuple you'll have the date as a string, sort of 288, 22, 11 or something like that. And then the next date, and so on. So you can see that the dates, the strings are nested inside tuples. That's why I have this other line here. So basically I go through each of those tuples and then I extract the first item of each tuple using this item 0. So therefore this new list will contain only the strings. So the first string of the first tuple, then the next string of the next tuple, and so on. So in here, this list will be a clean list of strings. Right, let me remove that, and then I do the same exact thing for temperature. So I get the cursor and I execute this method. So that's the same code as this. The only difference is that we're getting the temperature column here from the temperatures table. So the table is the same, but two different columns. Then finally, I provide the date list to the x variable and the temperature list to the y variable. And that's the labels of the graph. And then I render the figure, and that's the result. So thanks for listening to this video, or for watching it, or both. I know some exercises are quite hard, you get stuck at certain points, but then when I show you the solution, then it triggers something in your mind, so you really learn better, I would say, when you do some errors and then you see what mistakes you did, so that really implants into your mind that the concept's better. So don't worry if you do mistakes and if you don't solve some parts of these projects. So thanks a lot for following, and I'll see you in the next videos.